Let's look at problem 5 from the review sheet for exam 3. Again, a linear equation in one variable we want to solve. Any fractions? No. Any parentheses? Yes. Let's use our distributive property to remove them. 3 times x gives 3x. 3 times minus 4 is minus 12. Minus 2 times x is minus 2x. Minus 2 times plus 5 is minus 10. What about the expressions? Do we have any like terms in this expression that we can combine? Yes, we do. 3x minus 2x will give us 1x. Minus 12 minus 10 more. You owe $12, you owe 10 more, that's the same as owing 22. There are no like terms we can combine in this expression. Only one variable term. I want only one term in the equation that has the variable. I currently have 2 terms in that equation that have the variable. I want to get down to 1 by making one of those disappear. I'm going to make the 1x term disappear. I'll do that by subtracting 1x from that side of the equation. That makes that become 0. But if I take away something from one side of my equation, since my equation is a balance, I have to take away the same thing from the other side. So my equation now becomes negative 22 equals 3x minus 1. Next key word is isolate. I want to isolate the variable term. The variable term is not isolated. It's on the same side of the equation with this constant term. I want that constant term to go away. I'll make that happen by adding 1 so that it disappears into 0. But if I add 1 to one side of my equation, I must add 1 to the other side to keep my equation in balance. You owe $22, you have 1, that's the same as owing 21. And now the last step is to make the coefficient of the variable term 1. Right now it's 3. And any non-zero number divided by itself is 1. So I'll divide both sides by 3, and that gives me x equals negative 7. Negative 21 divided by 3 gives me negative 7. So if we were to take negative 7 and put it everywhere we have an x, and then evaluate the newly created arithmetic expressions, the value of this expression would be equal to the value of that expression. That's what it means to have found the solution to an equation.